Okay, we will discuss how to draw the Lewis structure. We have here carbon tetrachloride. First step, we're going to get the total number of valence electrons. So how to determine the number of valence electrons? We're going to use our periodic table of elements. Okay, and we can determine the number of valence electrons based on the group number. So for group 1, all of these elements, the valence electron is 1. Okay? For group 2, they have 2 valence electrons. And for the transition metals from group 3 to group 12, because their group number doesn't identify the number of valence electrons. We will continue to group 13. In group 13, they have 3 valence electrons. 14, they have 4 valence electrons. Group 15, they have 5 valence electrons. Up to group 18. So group 18, they have 8 valence electrons. We will just look at the group number to identify the valence electrons, except the transition metals. Okay? Now, okay, our first atom here is carbon. So we will get the group number of carbon. The group number of carbon is group 14. Okay, let's write group 14. Carbon belongs to group 14. Therefore, it has 4 valence electrons. Okay, and for the chlorine, let's check our periodic table. Chlorine belongs to group 17. Chlorine belongs to group 17. It has 7 valence electrons. Okay. Now, we have here number 4. It indicates the number of atoms. Therefore, we have 4 chlorine atoms. So, we have to multiply it by 4. Okay. So, we have the total of 28 valence electrons for chlorine. Then let's add 4 valence electrons plus 28 valence electrons of chlorine. We have the total of 32 valence electrons. So this is our total number of valence electrons. Step 2, we're going to choose the central atom. The central atom has the least electronegativity, except for hydrogen. When we say electronegative or electronegativity, this is the tendency of the atom to attract electrons. Okay? The electronegativity here increases from left to right. So our options are carbon and chlorine. Therefore, we will choose carbon. our central atom is carbon. And we're going to write 4 chlorine atoms here. Okay. Third step, we're going to draw bonds. So let's draw a single bond. Okay. The single bond is equivalent to 2 electrons. Okay. This is the representation of sharing of electrons. If you have your double bond, therefore it has 4 electrons. Okay. And triple bond with 6 electrons. Okay. Now, we already use 2, 4, 6, 8 electrons. Okay. So, our total number of valence electrons is 32 minus the 8 electrons that we already use to form bonds. Okay, to form bonds. So we have how many electrons left? We have total of 24 valence electrons left. Okay. Step 4, we have to allocate the remaining electrons to the outer atoms. We will distribute the 24 electrons. And take note that atoms become stable with 8 valence electrons. Based on the octet rule, okay, atoms are happy or stable with 8 valence electrons. Okay, except helium and hydrogen, because they are happy with 2 valence electrons, and that is duet rule. Okay, so to become stable, they have to have 8 valence electrons, except the helium and hydrogen, because they are happy with 2 valence electrons. We're going to distribute now the leftover 24. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, let's check if the atoms are stable. Let's see if chlorine is happy. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. the 4 chlorine atoms are already stable because they have 8 valence electrons. Now, how about carbon? 2, 4, 6, 8. Carbon has 8 electrons. So this is the Lewis diagram of carbon tetrachloride. Let's have number 2. We have here formaldehyde. Same process, we're going to get the total number of valence electrons. We have here carbon, hydrogen, and oxygen. We have to identify first the group number so we can determine the valence electrons. The group number of carbon is 14. The group number of hydrogen is 1. And the group number of oxygen is 16. Now, let us identify the number of valence electrons. For carbon, it has 4 valence electrons. For hydrogen, it has 1 valence electron. However, we have number 2 here. Therefore, hydrogen, we have 2 atoms of hydrogen, so we have to multiply here. 1 times 2. The product is 2 valence electrons. And for the oxygen, we have 6 valence electrons. Total number of valence electrons: 4 plus 2 plus 6. Total number of valence electrons, we have 12 valence electrons. Okay, next we're going to choose the central atom, the least electronegative except hydrogen. We have 2 options left, carbon and oxygen. So which one is our central atom? Because hydrogen will never be the central atom. Now, the electronegativity decreases from right to left. Okay? Decreases. We will choose between carbon and oxygen. Carbon is the least electronegative atom. Our central atom now is the carbon. Then we have hydrogen, 2 atoms of hydrogen, and oxygen here. Okay, step 3, we're going to draw bonds. Okay, how many electrons did we use to form bonds? We have 6. 2, 4, 6. Again, the bond or single bond is equivalent to 2 electrons. Going to subtract. This is for the bonds. Okay, so 12 minus 6 is equal to 6 valence electrons left. Okay, now step 4, we have to allocate the remaining electrons to the outer atoms. Take note that hydrogen is happy with 2 valence electrons. Okay, hydrogen. is stable with 2 valence electrons. So you do not need to add another electron here, okay, because hydrogen is already stable because of the bond. Now you're going to put the remaining electrons here in oxygen. Two, 4, 6. Okay. Now, atoms are happy with 8 valence electrons, except hydrogen and helium. Now, let's check if carbon and oxygen are stable. Let's check first oxygen. 2, 4, 6, 8. Oxygen is happy because oxygen already achieved full octet because of the 8 electrons. How about carbon? 2, 4, 6. Carbon has 6 electrons, so we need 2 more electrons. Now, you're not allowed to add more electrons because we have to follow the total valence electrons, which is 20. Okay? So, here in step 5, if central atom doesn't have an octet, create multiple bonds. We have to create another bond. We're going to use the 2 electrons here. Okay? At the top. And let's form a bond. Now let's check if oxygen is still happy. 2, 4, 6, 8. Okay, oxygen is still stable. How about carbon? 2, 4, 6, 8. So carbon is happy because it has 8 electrons already using the bonds.